So it's Axel Muller from University of Oslo. He's going to tell about the GREENPEG project toolset to explore for buried pegmatites hosting lithium, high purity quartz, and other critical raw materials. Please go ahead.
Yeah, thank you very much. So my talk is my name is Axel Muller from Norway. And I had a nice introduction to the pegmatites in general by Catherine, so I can save some time, hopefully. And how I want to explain you how to explore for pegmatites. It sounds very simple, but it isn't. Until 5 years ago, nobody really know how to explore for the pegmatites because they are, first of all, very small bodies. And second, their host rocks properties are often quite similar to the pegmatites themselves. So that means geophysically, they are basically invisible. However, I explain you in the next minutes how we improve the methods to find them. So we had a challenge. It's an EU project, which started in 2020 with a few days after the lockdown. As you can see, we nicely separated in 2 meters distance, our project members. But in Norway, it was even bigger challenge because we are used to keep a distance of 10 meters. So we are now happy to back in the normal. Anyway, so as I told you, this was a project. GREENPEG was funded by the EU. So we were 13 partners, 1/3 industry, 1/3 academics, and 1/3 non-profit organizations. The project will end this October, so you will basically hear results today. So you're very happy, so you're one of the first ones. We have also a project website, which will turn over in an expert consultancy website after 31st of October. So we will continue as a expert group after the project finishing. So the target, of course, are the pegmatite type deposits, which most important at the moment is lithium, but it's also silicon in the form of quartz and rare earths, tantalum, tin, and so on. And the objective was or is a multi-method and environmental economical viable toolset to explore for hidden or buried pegmatites. This toolset includes 3 instrumental developments and 2 data sets. And it will be, in the end, I will also explain you where it's getting published. So we divided our exploration methods in the province scale, district scale, and the prospect scale. All together, because we had so much money, we applied 35 methods. And these methods were applied in 3 brownfield exploration areas in Europe. So there's the Tysfjord area in northern Europe, northern Norway, where there are pegmatites mined for high purity quartz, which maybe sounds a bit unusual for you, but it's the second best quality of quartz in the world. So making quite a lot of money out of this quartz. Then the second area was the Leinster area in Ireland, where there are several spodumene pegmatites have been known since a while and are explored by a company. And the Wolfsberg area, which hosts the European largest spodumene pegmatite deposit in Europe. These are the 3 technical devices we developed. In particular, the piezoelectric seismograph might be of interest. So this uses the piezoelectric effect of quartz to see quartz-rich ore bodies underground. And the second one is the hyperspectral imaging system, a drone-borne one developed by a German company. And the third one, maybe the most biggest money maker, is the EASA-certified helicopter-compatible nose stinger magnetometer. It has been applied, of course, in Canada and the US, but in Europe we didn't have one. So that is the first in Europe. So you can reduce your flight distance over the ground a lot, meaning that you can get much higher resolution maps of radio activity and the magnetics. Part of the toolset, besides the technological developments, are 2 databases. That is one, the spectral library of European pegmatites and minerals and host rocks, which is freely accessible on the CENODO EU website. And on the right, you have the first petrophysical database, GREENPEG, of also pegmatites and host rock. The left one is for satellite image processing, and on the right side, the petrophysical database is to adjust your geophysical methods before you go in the field. A little about the toolset itself. This table shows you the structure of the toolset. The toolset itself, it's not a virtual thing, it's a 400-page document which will be published by the end of the year in Economic Geology. It's the first type of this publication in economic geology, and it's quite groundbreaking, I have to say. And I hope other working groups will follow this thing, that we maybe can develop for each deposit type, ideally, such toolsets. And it's also, the toolset is not stable. I mean, it also should be improved over the years by others or continued work. So it starts with the knowledge development. If in the case you don't know anything about pegmatites, then the desk study, which is already about your target area, where you have to determine the geological environment, exploration environment, and your financial environment. Then you choose the methods or the method combinations. Yeah, and then you just perform your survey, and hopefully you will get your pegmatite. This map has shown a little bit already by Catherine. It shows you the major pegmatite provinces here in different colors. The most economically more interesting are the blue spots and the green spots. Yeah, the Baltic countries here are a bit empty, but it's, of course, they are covered by sediments. But if you look at the distribution of pegmatites, the potentials that you have, actually pegmatites below the sedimentary cover in Estonia, it's quite high. So then we modified the mineral system approach for pegmatite deposits. On the right side is the classical model, which Catherine nicely introduced, where the pegmatites are related to granitic plutones. The extension is on the left side, where you can also form mineralized pegmatites by direct partial melting. Of course, we don't know the processes in detail, but that is somehow the fact. That's relatively clear now, that we can also produce mineralized pegmatites just by partial melting. Why is this so important, this mineral system approach? Because it changes actually your exploration methodology approach. On the top, you have the zonation of pegmatite fields according to the classical model, which still applies, for example, for the Variscan pegmatite fields, where you would find your most lithium mineralized pegmatites farthest away from your mother or parental pluton. However, if your pegmatite field is anatectic, you have a little bit of a problem, because your pegmatite fields are not so nicely zoned, and exploration becomes more complicated. So you have, let's say, 3 end scenarios. One scenario could be that your pegmatite field is bound to a certain lithology. The second one, that you have a vertical shear zone corridor, like in Ireland. Or you have a Paleos rust zone. There you may be relatively lucky, because there you have also kind of zonation of the pegmatite field. Yes, and we also applied the, or give advice for the environmental and social assessment in your target area. So of course, you have to follow the official guidelines. And then we tested several other guidelines for exploration, and it turned out that the E3 Plus advice is the most suitable for exploration for pegmatite types deposit. Sounds a bit strange. By the way, we did a lot of environmental investigations in our target areas. We had interviews with the local people, how they think about exploration and maybe future mining in the area where we were. In Norway, it was very positive, but in Ireland, we had a pub evening organized, and the evening ended that the people started to punch each other, and we had to leave the pub. But it was not basically because of us, but the local people had different opinions. So that shows even Yeah, and the major outcome would be here that is actually we have learned that even the exploration geologists, which are the first going in the field, these have to be educated how to deal with the local people. They have to learn about the local history. They have to learn how to talk to the people, because that is very crucial for their following process for the mine setup and so on. So that is one major outcome of this study. So here now you were wondering what is about the methods. So that's a complete list of the geophysical and geochemical exploration methods which may work, we prove that they work in certain settings for pegmatite exploration, ordered in province scale, district scale, and prospect scale. Then you have also the expert for each method from our GREENPEG consortium you can contact if you're interested in a particular one. Yeah, here are some snapshots from the toolset itself. So this is satellite image processing. So if you use the database which we developed, you were able by using Sentinel-2 satellite images to maybe by spectral band classification to identify pegmatites from the satellite images. However, the precondition is here that your pegmatites are exposed at the surface. This is an example of airborne geophysics with our new nose stinger, radiometer, and magnetometer. This is on the right side. It's a high-resolution radiometric map of the northern Tysfjord area in Norway. So you see the scale. It's 4 kilometers times 4 kilometers. All the pinkish areas are the thorium-uranium anomalies in the area, and they fall well together with the known pegmatites, which are in yellow. And then you see the question marks where the anomalies, but there are no pegmatites. And we went there, and where the question marks are, in each place we found a new pegmatite. So that was incredibly efficient in this case. So the pegmatites are here more radioactive than the host rocks. It was new. But we only managed this with a very narrow flight line spacing to see this in the airborne geophysics. And the good thing also with these pegmatites, they are not only radioactive themselves, they make also geochemical halo, which is also radioactive. And these halos actually are created by every type of pegmatites. They can also be used for geochemical exploration, even the pegmatites are not exposed. Very effective turned out also be the 3D electric resistivity. So this is it's a model of a buried pegmatite body in Tysfjord. Resistivity measurements does not work in every area. We know already in the tropics it's quite challenging. The resistivity is not so clear, for example, in tropical weathered areas. Then the application of the piezoelectric seismograph, it just sends so you have to initiate your piezoelectric effect by just with a sledgehammer or a little blast on the surface, and then you measure the electricity, in simple words, coming back, and you can model, in the ideal case, your underlying pegmatite body. And this basis on the piezoelectric effect of quartz. So you can also use these methods for quartz vein exploration, for example. Most important is that your ore body has more quartz, or also opposite less quartz than the surrounding. So it turned out to be a very efficient method. Then a new thing here for geochemical mapping, we use the quartz chemistry of quartz grains or of pegmatites themselves. On the left side, you see the total trace element content of quartz in different pegmatites provinces in the world. So the more colored ones on the right, the orange, yellow, and so on, that is quartz from lithium pegmatites with very high trace element contents. But the NYF pegmatites, also the rare earth pegmatites, and the bluish and dark violet have less trace elements in quartz, meaning these are suitable for high purity quartz production. That's the application. On the other hand, you can use the quartz grains to look for spodumene mineralized pegmatites. That is the aluminum versus lithium plot. So if you find a quartz grain or quartz crystal with lithium contents higher than 30 ppm and higher than higher than 30 ppm lithium and higher than 100 ppm aluminum, you're quite sure that your quartz grain comes from a spodumene pegmatite. So you can actually use quartz as a pathfinder mineral, which we have done here across the Eastern Alps. The map on the lower left here. The larger the circle of the diameter, the higher is the lithium content of the quartz. And you see the lithium content in pegmatite quartz in the Alp increases from west to east. And the biggest one is the green circle, which is the Wolfram, the Wolfsberg lithium deposit, the biggest in Europe. So we have a quite nice, even though only a few dots, geochemical map made or using just the quartz. That's quite fascinating. So now that was just theory, but our toolset has been applied, for example, by United Lithium in the Bergby lithium pegmatite province, which Eric mentioned today. So with our airborne new geophysical tool, they were able to narrow down the exploration target area, so we could support them to finding more spodumene pegmatites. So very prospective area. I agree with that with Eric. And most importantly, the biggest or the nicest investment of the European money was in the students. So we had a 2-week course to explain the toolset in praxis to students from all over Europe. So 12 students were invited to test our toolset, and they were very happy. Also because of the beautiful venue in the Lofoten. Yeah, and the project itself is already published. You can download for free, and the toolset will be published by end of the year in a special volume, Economic Geology. Thank you for your attention.
Thank you, Axel. Any questions? Torgill?
Yeah, Torgill Rasmussen here. Actually, do I have a lot of questions concerning the geophysics, but I'm not going to bore you with that now, but will the data be open, the raw data, so we can have a look ourselves?
Yes, also the toolset, this, as I said, is 400 pages. So with all the methods, and there we also, you will find precise measurement data from the test sites in the toolset to show examples for basically all geophysical methods which we applied. So and the parameters, you get also the parameters.
Okay,
from us.
So digital format.
Yeah, it's in a written format.
Well, I mean,
but the databases are digital, I mentioned. Yeah.
Okay, I'll have a look.
Yeah, the petrophysical database, for example, is digital. I mean, everything is digital in a way, but the toolset is so complex, we decided to provide it in a written form where the table and data are integrated. So
but for example, when it comes to the airborne geophysics, I mean, all the data will be available for download?
From the specific areas, we had the test sites. Yeah, this is with the geological surveys. They have the data. From their sites, you can download them. But we can talk directly if you have specific questions.
Yeah, because I think, I mean, first of all, I mean, this about the piezoelectric method is interesting, but I can also see a lot of problems related to that one.
Yeah, I can tell you the problem. That's the background noise.
Yes, exactly. Yeah. and I would of course like to see how it works in practice.
Yes. So this, I can give you the contact for the person developed.
Okay, very good.
Yeah. There's also publication in line just about this method.
Okay, I think we have to move on now. So we'll have the final talk before the post and coffee break. That's